So, our next video in this series of circuits is parallel circuits. You've seen why we don't wire loads in series. It just isn't going to work. So how we wire them is in parallel. And I'm going to draw out a parallel circuit here on the board, and then we're going to build it down here on our project board. Again, L1 and neutral. 120 volts will be our source voltage. Our conductor, our single pole, single throw switch. Our first parallel load will be our light. And return to neutral. Our second one, again, our light. And our return to neutral. As you can see, this schematic, this wiring diagram, is set up as a ladder. This is called a ladder diagram. It also shows the sequence of operations. Remember that term, sequence of operations. So, for either one of these lights to light up, the first thing that has to happen is this switch has to close. That's the first operation in our sequence of operations. Once this closes, both lights will light. And if you remember, the laws of voltage in parallel is each load uses the same voltage as our source voltage. So each one of these loads will have 120 volts because they're not sharing them. They get an equal amount. It's not going through one after another. And we're going to show you that on this circuit board. Okay. So, again, our power source, our switches, and our loads. We hook up to our L1, switch coming in, switch coming out. That's not there. Whoops. Switch coming out to our first load. Power coming out of our first load back to neutral. So at this point here, what we've done is wired from L1 through our switch, through our first load, and back to neutral. Now we're going to wire up our second load. We're going to take our power from the line side of our load and bring it over to our second load. Then we are going to take off of our other side and bring that back to our load side on that side, on that load. So let's go back to our drawing. We've taken off the line side of our load, first load, and brought it into our second load. We've come off our other side of our load and brought it back to our return on our first load, and they both go back to neutral. Power coming in, it splits here. One goes over here to our second load, the other goes through the first load and comes out on the other side. The power comes through our second load, comes out, comes back, and joins our return and travels back to neutral. We will now apply voltage, and we'll show you how it works. Throwing our switch, we now have both lights light. Pay attention to our meter. At our source, we have 120 volts. Our first light, our first load, shows 120 volts. Our second load shows 120 volts, or 119 and some change, I understand. So because they're in parallel, they're not sharing the load. Excuse me, they're not sharing the voltage. Each get the same amount. That is why we can wire it in parallel. If these were motors, condensing fan motor, compressor, they would both be able to operate on with the same voltage. Now, the only thing that would change on that would be the amperage. If this was a higher amp draw than this, the amperage would be different, but the total amp draw on these would add up to the total amperage from the circuit. If this was, say, 10 amps and that was 15 amps, the total amperage drawn on either here or here would be 25 amps. But individually, it would be 10 and 15 or 15 and 10.